The method I'm going to show you is the method called elimination and back substitution, and as I said, I'm pretty sure that you've seen it in high school, although perhaps maybe not with this particular name. Also, it is a method which is much better explained by showing you how to do it rather than by explaining theoretically how it's supposed to be done. Okay? I could do that, but it will be much more confusing, much more complicated. Also, I'm going to show it to you by using a very simple example of just two equations and two variables. The method is exactly the same when we have more equations and or more variables. The only difference is that it can get a little bit longer. Okay. So what does this system, what does this method consist of? Well, first of all, what we're going to do is we're going to rewrite the first equation as is, and from the second equation, I'm going to find out what the value of x is in terms of y. So in other words, I'm going to solve the second equation for x in terms of y. Why did I choose the second equation? Well, simply because in the second equation, x was already by itself, and therefore solving it for x in terms of y was fairly simple. However, nothing would prevent me from doing the other way around and solving the first equation for x in terms of y, or if it's more convenient, solve either one of those two equations for y in terms of x. So in other words, all we want to solve for one variable in terms of the others. In the next step, what I'm going to do is I'm going to take now that value, which of course is the value of x, because I'm saying that x is equal to that, and I'm going to put it into the in place of x into the other equation. Okay, so that means I'm going to leave the second equation as is and change the first one to the equivalent one. Notice again, I'm not really changing anything. I'm just changing the way the two equations look. So obviously this does not change the solutions of the system. So at each step, I'm changing each system to an equivalent one. But without changing the solutions. Now, this is the elimination stage. Remember, this is called elimination and back substitution. So it's called the elimination stage because, of course, I've eliminated the variable x from the first equation. And again, if you have more variables or more equations, what you do is you eliminate one variable at a time and leave fewer and fewer variables. Now that the first equation only has y as a variable, I can solve it for y. So collect all the terms with y on the left hand side, all the constant terms on the right hand side, divide by the coefficient, and now I know that y has to be equal to negative 14 over 11. But that doesn't tell me what x is yet. So what I need to do is I need to take that value of y and plug it back in place of y in the second equation. Okay, and this is the back substitution step. So what I'm doing here is I'm using the value I have found for y, and I'm substituting it back into the equation of x so as to obtain the value for x. Okay, so now I know that y has to be negative 14 over 11 and x has to be 13 over 11. Therefore, the solution is the vector x given by 13 over 11 minus 14 over 11. Okay. Now, in some situations, you may prefer to write the solution as x equal 13 over 11 and y equal negative 14 over 11. That's fine as well. But just to become more and more familiar with this whole structure of vectors and the relationships between vectors and systems, I would recommend that you actually always express the final answer as a vector. Alright, and that's it for this introductory class. Now we're going to do some exercises in class. You're going to do some work on your own to become familiar with all these things, with all these terms, and with the elimination and back substitution method. But let me tell you some things that will sort of point the way to what's coming next. Okay? This method of elimination and back substitution is definitely a method. It works. In fact, it can work for any system of any number of equations in any number of variables. But it is tremendously long. It can be tremendously long and tedious. The example I showed you was very short because I used a very small system of two equations and two variables. So what we're going to ask ourselves is there a better way? And this reminds me of what Winnie the Pooh was asking when he kept being brought from the upper floor to the lower floor by banging his head on each step of the stairs, and he kept asking himself, there's got to be a better way. Well, in fact, there is, and that's what we're going to be looking in the next class. And in fact, that method is not only more efficient for solving systems, but as I said earlier, it's going to be tremendously fruitful in terms of new ideas, new applications, and new developments.